Step 5. Carefully excavate several segments of row, including some in harder or drier areas such as combine tracks, as well as in moist or soft areas. Step 6. Is the furrow at a consistent depth, not varying more than 1/4 of an inch, and at the intended depth? Far too often we see people finding insufficient depth and adjusting the gauge wheel mechanism to a deeper setting without ever checking to see if the shallow depth from the previous setting was due to insufficient downforce on the opener. Always check the furrow depth in a softer or more damp area to see how deeply it was penetrating there. If that depth is considerably greater than the depth in the harder or drier spots, then the problem is inadequate downforce on the row unit. This may be caused by the down pressure springs or airbags not supplying enough force, or by inadequate weight on the frame. Try increasing the down pressure settings on the springs or airbag system. If the planter frame is being lifted, you will see a change in the angle of the parallel linkage after you increase the downforce setting and pull the planter ahead again. If you carry fertilizer tanks on the planter, you may observe changes in the parallel link angles as the tanks get closer to empty. These are signs you must increase the frame weight to be able to create enough downforce on the opener units for this particular setting on the down pressure springs or airbag system. Also, be aware that any sideband fertilizer openers being used will have their own down pressure requirements, which subtracts from the total frame weight available for supplying downforce on the row units. Since sideband openers don't need to run very deep to be agronomically satisfactory, nor do they need to be consistent in depth, it makes sense to run the sideband openers at a shallow setting and with light spring pressure. We will discuss sideband fertilizer openers further in a moment. Down pressure and frame weight must be set correctly before proceeding with steps 7 through 10. If down pressure or frame weight requirements change during the planting season, you will need to recheck steps 7 through 10. Changes in the stubble type may require different down pressure and depth settings. Also, faster planting speeds will require more down pressure. As you gain experience with no-till seeding, you will become fluent in predicting what changes must be made during the planting season. However, it is always important to monitor the results closely. Continuing with step 6, if separate side banding fertilizer openers are used, check the depth and location laterally from the seed row. From an agronomy standpoint, fertilizer openers only need to go 1 inch to 1.5 inches deep. Anything deeper requires tremendous frame weight and spring pressure and causes unnecessary soil compaction. Fertilizer openers will preferably be placed 3 to 5 inches away from the seed row. Seed placement can be adversely affected if the fertilizer cut is too close to where the seed opener will run. If high nitrogen rates are being placed, it can be especially hazardous to your stand if the fertilizer openers are too close to the seed row. Many of these single-disc fertilizer openers will tend to creep laterally, so it is a good idea to recheck them occasionally, or put a spot of weld on the bar to prevent them from creeping. Step 7. If row cleaners are being used, look at how much residue has been moved out of the row area. Look at all the rows to get a better idea. If some rows are noticeably more or less aggressive, check to see if the row cleaner is set differently, if the bracket is bent, or if the row unit depth is set differently. Adjust row cleaners to move 30 to 50% of residue and not disturb any soil. Properly adjusted row cleaners may not be turning continually in the field, but they're still doing their job. Coulters generally hinder good seed placement and shouldn't be used. Step 8. If adjustments were made in steps 6 and 7, run the planter again. Carefully excavate several segments of row, being careful not to disturb the seeds. Are all seeds in the bottom of the furrow? What percent isn't in the bottom? If you find any seeds not in the bottom of the furrow, check the seed tube for cracked or frayed edges. Also check for premature sidewall collapse. In other words, how crisply the furrow is defined before the closing wheels have altered it. For this evaluation, you can eliminate the effect of the spoked closing wheels by tying up any closing bracket on a row or two. Premature sidewall collapse or blowout has many causes, including reduced inner diameter or RID gauge tires, as well as inadequate down pressure on the regular gauge tires. Essentially anything not keeping the inner edge of the gauge wheel firmly on the soil surface. Rusty opener blades will also cause more sidewall lift or collapse until they get shiny again. If you have chosen to run RID gauge tires, realize that the furrow will not be crisply defined. This photo shows the amount of soil heaving permitted by the RID tire. Most of the upper part of the sidewall has lifted and fallen into the furrow, which is indeed helpful in managing sidewall compaction, but very detrimental to seed placement, since the sidewall is what guides the seed to the bottom of the furrow. Also, seed scattered amongst the chunks of sidewall will not come into contact with the in-furrow seed firming device and may not germinate. If you have chosen to run RID gauge tires, monitor them closely as soil conditions change. The vast majority of seed should be properly placed and firmed, or else you are compromising too much with the RID gauge tires. Blades flexing inward away from the gauge wheels also cause more sidewall lifting and collapse. Blade flex is caused by worn or thin blades and by worn seed tube guards. These problems can be eliminated by using the thicker 3.5 millimeter blades now offered by most planter manufacturers and by using RK Products hardened steel tube guard. See the setup section of the video for more details. Also, anything loosening the soil ahead of the seed opener can cause the seed trench to be poorly formed. Coulters ahead of the row unit, fertilizer openers running too close, or anything else disturbing the soil or altering the function of the opener blades will cause problems. Step 9. Are all the seeds embedded in the bottom of the furrow? Good seed-to-soil contact is essential for consistent germination, and the seeds should be securely tucked into the bottom of the furrow. In drier climates or high clay soils, the seed should be embedded sufficiently that it must be pried loose with a pocket knife. If seeds are not firmed adequately, check the pressure on the firming device, such as the Keaton or in-furrow firming wheel. You should have some difficulty pulling the firming device out of the furrow with your fingers. You can increase the pressure on Keatons by tightening the tensioning screw. If more is needed, Exapta's Mojo wire will apply 3 to 5 times more pressure to a Keaton. If some seeds are loose despite good pressure on the firming device, again look at premature sidewall collapse, which was step 8, and specifically caused by dust and portions of the sidewall falling in ahead of seed, or seeds bouncing into lateral fissures and not being engaged by the firming device. If you replaced your opener blades and seed tube guards to make a wider furrow, but you are running old Keatons that have worn to a knife edge on the bottom, the Keaton may not be engaging all the seeds, or may be pushing them sideways instead of downward. Replace the Keaton if necessary. Also look for seeds being pulled loose by spoke closing wheels, which was evaluated in Step 8 by comparing the row or rows with closing wheels tied up versus those that were not. If there are significantly more seeds misplaced on the rows with the spoke closing wheels engaging, then they are the culprit. Long, slender spokes can easily go too deep, which increases the likelihood of pulling seeds loose. This can be alleviated by reducing spring pressure on the closing bracket, by spacing the closing wheels further apart, or by going to a spoke closing wheel with more appropriately shaped spokes. Note that OEM closing bracket springs are much too stout for use with spoked closing wheels. You may need to replace this spring with a considerably lighter spring to have the fine increments of adjustment you'll need during the season. Exapta offers one such spring. If you are using Exapta's products that create toe out on the closing wheel, this also causes the spokes to engage more aggressively. This can be fine-tuned by removing the toe out wedge or by turning the wedge 1/8 or 1/4 of a turn to lessen the toe out.